Hello, my name is Ivan Losuk, engineer at SUSE, and I would like to present you a short description of Kubernetes. Kubernetes is a container orchestrator. That means that it's going to deploy our applications in containers. For that, Kubernetes uses a container engine. That could be, for instance, Docker. Kubernetes is not the only orchestrator in the market. There are others, but this is the really widely used. Kubernetes do magic. We only have to describe what application we would like to have, and Kubernetes is going to try to deploy this configuration. But also, it's going to try to maintain this status whatever happens, until we change that configuration. Sometimes it won't achieve that, because it depends on the resources. We saw that Kubernetes is good for deployment automatization. But also, something really important is that you could scale your application really fast. Another feature is that you can upgrade your applications with newer images, and Kubernetes is going to ensure that this process works with no service interruption. Also, Kubernetes takes care of your applications, doing constant tests and trying to recover these applications when something wrong happens. Interesting feature is that Kubernetes can limit the resources consumed by the applications. Kubernetes allows hot adding and removing resources as nodes, and also provision these resources. Kubernetes is good with network and disk security. For instance, allowing role user access to some parts of the deployment. Kubernetes clusters, there were two kinds of nodes, masters and workers. The core of Kubernetes cluster services, and its API live in each master node. We could have a simple master, or we could have a bunch of masters nodes to ensure the high availability. The workers are the container host and has two things: a container engine, most used is Docker, and a service called Kubernetes to communicate with Kubernetes. In this image we can see only Kubernetes core with an API and different workers. Each one has the Kubernetes and the Docker engine. And now, how do we specify what Kubernetes has to do? We could define a deploy with a YAML file with at least three things: some metadata to describe and classify the deployment, the image for the container, for instance, an image for Apache Docker, and the number of replicas we want. We could choose more than one to have high capacity to answer the requests and guarantee the high availability. Additionally, we usually add some of these, some live proof tests and some environment variables. In this example, we have an application, app1, with 2 replicas, and another application, app2, with 1 replica. Kubernetes is going to try to balance the load and to try to put each instance of the same application in different nodes to prevent that the failure of this node will interrupt this application availability. Replica is called a pod. A pod contains at least 1 container, but sometimes has more, for instance, to collect metrics. There is a special deployment. Sometimes we want to keep the state of the container and its files, for instance, for a DB service. Then we will use stateful sets and disk provision. In a stateful set, we provision some disk space to store the application data. Kubernetes didn't mind where it's stored, only needs a plugin called storage class to manage. Could be Amazon, Azure, Google Block Stores, Ceph, Cinder, or others. How does Kubernetes do the job? For instance, a pod failure. The pod app1 in the worker 2 has died. Kubernetes is going to create a new pod to maintain the number of replicas. In this other case, the worker 2 has died, and Kubernetes will create the pods where in this worker in another worker. In this last example, we need to update the pods of a deployment with a new image. Kubernetes will stop and recreate 1 pod every time to ensure that the service doesn't interrupt. If the creation of pod fails, all the process stops to allow investigate the problem without interruption of the service. In this first step, Kubernetes creates a new pod with the new image version in the worker tree. Then Kubernetes deletes the replaced pod and creates a new pod for the other old one. Finally, Kubernetes deletes the last old pod, and we have our version 2 in each instance of application 1. Thank you for your attention. This is Ivan Losuk from SUSE.